Today we're going to be looking at squares and cubes. We're going to talk about perfect squares, cubes, and surface areas of those cubes. So let's get our icons. I can write and explain the formula for the volume of a cube, including the meaning of the exponent. Talked a little bit about that. When I know the edge length of a cube, I can find the volume and express it in using appropriate units. I can write and explain the formula of surface area of a cube, and I know when I know the length of the edge length of a cube, I can find its surface area and express it in using appropriate units. So I hope you copied down the words off the screen as opposed to listening to me stumble over reading them right now. And if you've got everything set, then you're ready to move on. So first thing we're going to do is we're going to look at perfect squares. So perfect. Some numbers are called perfect squares. Now there's some reasoning behind that. Here we've got a square that has equal sides. So this would be something that would fall into that category. Not all numbers are perfect squares. These make other shapes. We do make a rectangle, which is not something that talks about like a perfect square. But remember, with the definition of a square, we're talking about something that has an equal, two equals, or all four sides are equal with right angles. So 9 is a perfect square. How do I know that 9 is a perfect square? Well, the area of this square right here is 9, because I have 3 times 3 makes 9. So any number that when you multiply together is something that is a perfect square. So 9 is a perfect square in this situation because you can take 3 times 3 to make it up. So you can figure out 4 other numbers that are perfect squares and 2 numbers that are not perfect squares. Okay, so should have gotten those answered and put into your answers just a second ago. So things like, we could use this entire space if we wanted to. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 25 is a perfect square because 5 times 5. 2 times 2. Let me grab my handy pen here. Oops, not that one. 2 times 2 makes a perfect square. So if I go, whoops, hang on a second. If I go 2 by 2, that makes 4. 4 is a perfect square. If I make 4 by 4 as a square, that makes 16. 16 is a perfect square. Okay, and I'm sure you've come up with lots of others. There's plenty of them that we could do. Look at number 2. Area. A square has a side length of 7 kilometers. What's the area? Well, you may have used this already, but it should be 7 times 7, which is 49. And remember, we talk about that in square units. So this is how that square units piece comes into play. As you talk about force and motion, you'll talk about that as well when you're talking about speed and such in science. Talk about on this last one here, area is 64 square centimeters. So if it's a square, that means that 64 is a perfect square. So what is one of the side lengths? Yeah, I hope that you know that 8 times 8 would give us 64 square centimeters. So 8 centimeters would be one side. Just like we have perfect squares, we have perfect cubes. So let's take a look at some perfect cubes. Some numbers, again, are perfect cubes. This would be a perfect cube. perfect cube would have squares on the sides. So if a perfect square was a number that you could make by multiplying by itself and getting a regular whole number, then same thing with a perfect cube. So this perfect cube, we have 3 by 3 by 3. So 3 times 3 is 9, times 3 is 27. So 27 is a perfect cube. So once you try, same thing we just talked about a second ago, but this time find some numbers that are perfect cubes and others that are not perfect cubes. A lot of them you could have come up with. Could have done easily some things like you could have used 2 times 2 times 2, which would get you 8. So 8 is a perfect cube. 27 is a perfect cube because 3 times 3 times 3. Could do 4 times 4 times 4. 4 times 4 is 16. And then times 4 more would get you 64. So you can see that cubes start going up even faster. Oops, looks like I answered number 2. So the side length is 4 centimeters on a cube. Its volume would be 64 square or cubic centimeters. What about this one? Cube has side length of 10 inches. What's the volume? Okay, well, that would be 1,000 cubic inches, right? Because 10 times 10 is 100. And then another times 10 would get you 1,000, so 1,000 cubic inches. So basically, this says here, a cube has, we don't know, side length units. What's the volume? Well, if we don't know what the number is, we do know that it's going to be whatever cubed, right? So if it's, so any number, when we find the volume, it's going to be cubic. So like if it's units, if it was 1 unit, it's going to be cubic units. I think we kind of talked about this a little bit ago. We have that 10 cubed, or 10 to the third power here. And we talked about what that means, right? Yeah, it means that you're going to multiply 10 times 10 times 10. So this is another way that these previous things that we've worked on builds into that. So when we multiply two numbers together that are the same, we're squaring those numbers. And that's why we would have the little 2 up beside it. So since 5 times 5 is 25, we can also write it as 5 squared, or 5 to the second power, equals 25. And we can also say that 25 is a perfect square, because remember we talked about earlier that if it's a whole number that we multiply by itself and it gets another whole number, that means it's a perfect square. Let's jot some definitions. So an exponent is, in an expression, it's that little number next to a full-size number. Tells you how many times to multiply it by itself. So like for example, 5 to the cubed would be 5 times 5 times 5. 8 squared would be 8 times 8. Squared just means that it's another way to say to the second power. Cubed is another way to say to the third power. And just like we talked about a minute ago with squared, multiply 3 numbers together, we're cubing those numbers. So in this example of 4, 4 cubed is 64 because it's 4 times 4 times 4. We can also say that 64 is a perfect cube. Some numbers can end up being a perfect cube and be a perfect square as well. There's not a lot, but they're oftentimes you're going to have your perfect cubes be much larger because, again, you're putting in that third number there. So what we've always talked about with area before, or even volume, when you talk about area, it's a length times a width, which gets you a square unit. Well, that's why we call it square, or that you write it as, like in this example, that you would write it as square over here. That should say inches. Hang on. So 5 inches for a side length gives you an area of 25 square inches, which you can write as that inches with the exponent of 2. Same thing with cubic. If you're using 4 centimeters for one of the edges length on a cube, length times width times height gets you 64, so that's 64 cubic centimeters. So when we multiply two numbers like 10 times 10, we can say that we're squaring them. So like if we write 10 to the second power equals 100, we could say 10 squared is 100. When we do three numbers, that's called cubing. 10 to the third power, or 10 cubed, would equal 1,000. Exponents are also used for writing the square units. So if we talk about the area of a square with a side length of 7, you could say it as 7 squared square kilometers. Well, 7 squared would be, I hope you know, 49, and then 49 would be a perfect square, wouldn't it? Same thing with the volume of a cube. This shouldn't be 2, hang on. And volume of a cube with the side length of 2 millimeters would be 2 cubed, and it would make cubic millimeters. Well, 2 cubed is 2 times 2 times 2, which gets you 8. So even if we don't know on a cube what the length of the side is, and we have just a letter there, just, as a placeholder for a number, we can still say that it's whatever that length is, in this case s, it'd still be cubed to find it. Area of a cube has 6 faces that are all identical. So if we're going to find the area overall of the surface area of a cube, we would take, since the edge side is still s in this situation, it'd be s squared, right? Because s times s. And then we'd have to multiply it by 6 because we have 6 copies. So it gets to be 6s squared would be a way that we could represent that square units for the surface area of a cube. Okay, a little long here, but I hope that you've gotten all of your information down and copied, and go on to your practice. Make sure that you ask any questions if you need to, and have a great day.